Welcome to the session on differentiation, second-order derivatives. The objectives for this session are to find the second-order derivatives of a simple function. To find the rate of change of the gradient function, you can differentiate again. Differentiating a function y equals f of x twice gives the second-order derivative f double dash of x, or d2y dx squared. Let's take a look at an example. If y equals 3x to the power 5, we can differentiate by using this formula to obtain dy dx equals 15x to the power 4. We can differentiate this again by using this formula to obtain d2y dx squared equals 60x cubed. dy dx is the gradient function which describes the rate of change of x. And the second derivative, d2y dx squared, is the rate of change of the gradient function. Let's now take a look at some notation. For a function y equals f of x, the first order derivative is given by f dash of x, or dy dx. And the second order derivative is given by f double dash of x, or d2y dx squared. Let's now take a look at another example. Given that y equals 2x to the power 7 plus 4 over x cubed, find dy dx and d2y dx squared. So let's solve this. We can rewrite y as 2x to the power 7 plus 4x to the minus 3. Let's first remind ourselves again of the rules for differentiation. If y equals ax to the power n, then dy dx equals an times x to the power n minus 1. Now in our example we are also required to find d2y dx squared, so we need to differentiate again. If we apply this rule again, then we can obtain the formula for d2y dx squared. So applying the formula again gives us d2y dx squared equals a times n minus 1 times x to the power n minus 2. So let's first find dy dx. Applying the highlighted formula, we obtain 2 times 7 times x to the power 7 minus 1 for the first term, and 4 times minus 3 times x to the minus 3 minus 1 for the second term. And tidying up, this gives us 14x to the power 6 minus 12 times x to the minus 4. As shown. And now for d2y dx squared. Applying the highlighted formula gives us 2 times 7 times 6 times x to the power 7 minus 2 for the first term, and 4 times minus 3 times minus 4 times x to the power minus 3 minus 2 for the second term. And tidying up gives us 84x to the power 5 plus 48x to the minus 5. and hence we've found dy dx and d2y dx squared. Now let's try another example. Given that y equals 7 root x plus 6 over root x, find f dash of x and f double dash of x. So let's solve this. We're rewriting y in a form that will allow us to calculate dy dx, or f dash of x. So 7 root x becomes 7x to the power a half, and 6 over root x becomes 6x to the power minus a half. And therefore, differentiating the first term, applying the highlighted formula, gives us 7 times a half times x to the power a half minus 1. And to the second term, we obtain 6 times minus a half times x to the minus a half minus 1. Of course, we've simply applied the highlighted formula. And tidying up gives us 7 over 2 x to the minus a half minus 3x to the minus 3 over 2. And differentiating again, using the formula for f double dash of x, and applying it to the first term, gives us 7 times a half minus 1 times x to the power half minus 2. And applying it to the second term gives us 7 times minus a half minus 1 times x to the power minus a half minus 2. And tidying up gives us minus 7 over 4x to the minus 3 over 2 plus 9 over 2 times x to the minus 5 over 2. And so we've found f dash of x and f double dash of x. This brings us to the end of this session. If you have understood its contents, you should be able to find the second order derivatives of a simple function. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.